Hey guys, welcome back to another notes video. Today should be the 22nd, I believe. I don't even know what the days are at this point, but whatever. If you're putting your date on your notes, just put whatever day that it is. Today we're moving on a little bit. We're continuing with area, but this is 10.2. This is going to be area of 3 other figures, trapezoids, which we have looked at. Rhombi, which is the plural of a rhombus, and then kites. Okay, we looked at these a little bit when we did, what did we even do? I don't even know what it was. It was like, I don't know, perimeter or something. I don't know what it was, but we looked at these shapes. I just don't remember what we were doing with them. But this time we are going to be finding the area of them, and this isn't like last time when we found perimeter and area. This time we're just going to find the perimeter, or the area, I mean. Alright, so we have 3 different shapes: a trapezoid, a rhombi, and a rhombus, and a kite. Let's start with a trapezoid. I'm going to give you the formulas of these shapes first, and then I will tell you, we'll do some examples together. Okay, so trapezoid looks something like this. Oh my, that's terrible. But anyways, so I'm going to, let me just try again. I'll tell you like what the all the different sides are called. Oh, that's much better. All right, and then we'll do some examples. So in a trapezoid, you have these 2 are parallel. These are called the bases. So this is a base, and this is a base. If you want, you can say base 1 and base 2, but it doesn't really matter. And then, as always, I've always told you the height is from the very top to the very bottom. So this right here is the height. Or you could also say, like, this is the height. It doesn't matter, as long as you're going from the top to the bottom. So, area of a trapezoid. The formula is 1/2 height times base 1 plus base 2. Okay, alright, as always, highlight, star, square, whatever you need to do. There is area of a trapezoid. I'm going to write trap, just so we remember. Alright, area of a trapezoid. So, example number 1. Let's just go ahead and get into it. Okay, we have a trapezoid here. And the top base is 28 centimeters. The bottom base is 58 centimeters. And the height is 30 centimeters. So, as I say, we just plug and chug. The area is 1/2 the height times base 1 plus base 2. So we have 1/2. The height is 30. The first base is 28. The second base is 58. No, it does not matter which is base 1 and what is base 2. Doesn't matter at all. What's really important is that you get the height in the correct space and the base is in the correct space. So, if you do that calculation in your calculator, you will get 1,290 centimeters squared, remember. And that's the area. Simple and easy. Okay, that is a trapezoid. Already moving on. Look at us going right along. I'm trying to make the notes a little bit quicker because they've been pretty long in the past. I'm sorry about that. Next we're going to, let's do one more example with trapezoid. This one's a little bit harder, actually. Alright, so here is our trapezoid this time. Okay, this one's a little bit harder. So, you have dotted line, which is 4 inches. This is X. This is 4 as well. The slanted line is 8.5 inches. This whole thing is 10 inches. This part will be L, and this part is the same as X. Okay, so let's break this up, okay? Let's find one part at a time, okay? Let's see if we can find, I think the easiest thing, the only thing we can find right now is L, okay? And we can use the Pythagorean theorem to do that because this is a right triangle. So let's say L squared plus 4 squared is 8.5 squared. Okay, I trust that you all can do this. It's like 16 and 72.25, something like that. Anyways, L equals 7.5. Okay, so that's the first thing that we have. Now let's see if we have all of our information here. If L, I'm going to erase L and put 7.5. If L is 7.5, 10 minus 7.5 will give us X. So 10 minus 7.5 is 2.5. I'll do it over here. 10 minus 7.5 is 2.5. So that's what X is. Everything's identified. Let's go ahead and do our equation. Okay. 1/2. So the height here, this is kind of like upside down or kind of on its side. So let's imagine that this long side is the base, is the bottom, okay? Then the height would be 4. And our two bases here, the long one is 10, and then the short one on the top, I'm using air quotes for top because if we flip it over, is 2.5, okay? So what I'm doing is I'm flipping this around so where 10 is on the bottom now and 2.5 is now on the top. So those are our two bases and our height is 4. If we do that in our calculator, we get 25 inches squared. Okay, that was a little complicated. I probably won't give you that many like that, but just in case you see one somewhere, there you go. And again, like I said last time, these are a lot on standardized tests. They're not just going to give you this simple formula with everything you need to know. They're going to ask you to figure it out. Okay, so that'll be really the hardest one we do. And like I said, I probably won't give you one of those on the test or in the homework. Let's continue to rhombi. Rhombi. A rhombus is something like this. That's a rhombus. And remember, a rhombus has diagonals, which are equivalent on the different sides. And then a kite, I'm going to do a kite to the side here. They use the same formula because they're kind of the same figure. Oh my goodness. I'm horrible at drawing, you guys know this. Alright, there's a kite, and it also has diagonals. Okay, so the formula for a rhombus or a kite, it's the same one. It is half the product of the diagonals. So, area is half the product of the diagonals. Diagonal 1 times diagonal 2. Okay, so let me just go ahead and label. I'll do it in blue. This would be diagonal 1, and green would be diagonal 2. I'll do it over here as well. Diagonal 1 is in blue, and diagonal 2 is in green. I'll even put it right here. Okay, so like I said, these are the same examples. So I'll do one example that will cover both of them. Okay, so let's do example, I don't even know what the example this is. I think it's 3. Okay, and it again is just to find the area. Here's our shape. I don't even know if it's a rhombus or a kite. Who even cares, you know? Okay, this is, I guess it's gonna be a rhombus. Okay, so here is 10 feet, and the green is 12 feet. And that is all it gives us here. So let's see here. By the markings, we know that these two blue sides are going to be equal, so that's 10 feet as well. And it doesn't look like it, but these two green sides are going to be equal as well. So this shouldn't be that bad. If the area is 1/2 D1, D2, we just say half of the blue one is 20, because we added them together, and the green one is 24, because we added those together. And in your calculator, you should get 240 feet squared. Okay. That was not bad. And we just have one more example, and then we'll be finished. This is example 4. Example is a little bit different, or example 4 is a little bit different than the other ones, because this time we have the area and we're going to solve for a missing side. Okay, so let's say we have a kite here. We have a kite. This diagonal, the blue one, and the green one. So let's say the green one is x, and the blue one is 2 times x. Okay, we know the area is 169. So let's try to solve for x. All we have to do is solve for x. We don't have to find both measures. Okay, so our formula here, a equals 1/2 d1, well, that's a b, d1 times d2. So the area is 169. D1, I guess it doesn't really matter, but I'll just say D1 is x, D2 is 2x. Okay, so that's, bring down the 169. The 1/2 and the 2 actually cancel. So 1/2 and 2 cancel. We have x times x, which is x squared. And then just take the square root. So the square root of 169 is 13. And that's what x is. So I don't think these area problems are too hard exactly. It's kind of just plug it into your calculator. But it can be difficult sometimes to identify like what you're looking for, what part is what. So just be on the lookout for that kind of stuff. Again, you'll have some practice problems tomorrow. But if you have any questions, just let me know. So that is the area of trapezoids, rhombi, and kites.